Hello everyone. Our lesson today is lesson 2 in unit 4, which is position of a point and a straight line with respect to a circle. We said before in lesson 1 that the circle divides the plane into 3 sets of a point. First, on the circle. Second, inside the circle. Third, outside the circle. Here we talk about the position of a point and a straight line with respect to a circle. First, we have position of a point. Okay, here we have 3 cases. Number 1, A inside the circle M. A outside the circle M, like here. Here we have the point A outside the circle. Okay, what's the relation between MA and this radius? Of course, MA greater than the radius. So if the point located outside the circle, so MA here will be greater than the length of the radius. Okay, second case, here we have A on the circle. Here, if A on the circle, so MA here is called a radius. So MA equals R. Okay. Third case, here we have A inside the circle. Like here MA. What the relation between MA and all the radius? Here MA smaller than the radius. Okay, so we have 3 positions of a point with respect to a circle. First, if the point outside the circle, so MA greater than R. If the point on the circle, so MA equals R. If the point inside the circle, so MA smaller than R. We have an example. A circle M is with radius 5 centimeter and A is a point in its plane. Okay, A here locate outside or on or inside the circle. Okay, we have here some examples. Number 1, here MA equals 5. So M and the radius equals 5. So MA equals the radius. So it's case number 2. Here A located or lies on the circle. Why? Because here we have MA equals R. Number 2, MA equals 3 centimeter. So MA here is smaller than the radius. So A lies inside the circle M. Why? Because MA less than R. Number 3, here MA equals 6.5. So MA is greater than the radius. So here A lies outside the circle. Why? Because MA greater than R. Okay, the last one, here MA equals 0. So here A is the center. Why? Because A don't remove. Here MA equals 0, so we don't have distance between M and A. So here A lies inside the circle and A becomes the center of the circle. Why? Because MA equals 0. Okay, we have another example. Example number 2. Here, if M is a circle of radius 5 centimeter and A is a point in the plane. Okay, here we have MA equals 3x minus 1. Find the value of x when A lies outside the circle and inside the circle on the circle. First, if A lies outside the circle, since A lies outside the circle, we have rule MA greater than the radius. By substitution, here MA 3x minus 1. So here we have 3x minus 1 greater than, here 5 equals 5, radius equals 5, and it's an inequality. Move negative 1 in the other by positive, so 3x here greater than 5 plus 1. It means 3x greater than 6. divided by 3. So x here greater than 6 divided 3, which is x greater than 2. So we have here x greater than 2. It means the values of x is an interval, open interval, because 2 here we have not equal. So open interval 2 and infinity. Okay? Number 2, inside the circle. What's the meaning of inside the circle? Since A lies inside the circle. So here we have MA smaller than R. Also substitution. Here we have MA is 3x minus 1. Okay. And if MA is smaller than R, as in the third example, here we have equals 0. So we have here another condition, which is MA greater than or equal 0. It means MA equals 0 and A becomes the center. Okay, so MA here is greater than or equal 0 and less than radius. So we have here MA greater than or equal 0 and less than the radius by substitution. Here we have MA 3x minus 1 greater than or equal 0 and less than 5. Move negative 1 in the two sides by positive. So we have here 0 plus 1, which is 1, 3x, 5 plus 1, which is 6. Okay, divided by 3, both sides, so 1 over 3. Here x, 6 divided 3 equals 2. So here x is belongs to close the interval because here we have equals. Third and 2 open. Okay? Here the last one on the circle. On the circle, it means here MA equals R. So since A lies on the circle, it means MA equals radius equals R by substitution. Here 3x minus 1 equals 5. It's an equation. Okay? Also move negative 1 in the other by positive. So 6 plus 1 equals, 5 plus 1 equals 6. Move 3 in the other by divided. 6 divided 3, which is 2. So the value here of x equals 2. Okay? Okay. Second, position of a straight line with respect to a circle. Okay? Second, as we said, position of a straight line with respect to a circle. We have here table. First, if MA greater than radius, we said in the point, it means the point located outside the circle, or the point lies outside the circle. Here we talk about straight line. So if MA greater than R, so the straight line is lies outside the circle, like in this example. And MA here is must perpendicular to the straight line L. It means we have here angle 90 degree, of measure 90 degree. Okay. And L, the straight line L, intersect the circle M is phi, because we have no intersection. And the surface, what's the meaning of the surface? The surface, it means here, all the surface here is the shaded part. Okay. L intersection the surface circle M is phi. Okay. Number 2, if MA equals R, it means here the straight line L is tangent to a circle A. Okay. It means here we have a straight line L is perpendicular to MA. And we called here L is a tangent. And A here is called point of tangency. Okay, again, if MA equals R, it means the straight line L is called a tangent to the circle M. And A here is called point of tangency. Okay, here we have L intersection the circle M is the point A, and also L intersection the surface area of circle M is called also the point A. The last one, here MA smaller than R. It means here the straight line is cut the circle. What the meaning of cut the circle is called secant. It's called secant to the circle M. Okay? Here also we have L intersection the circle. We have here 2 points, which is X and Y. And L intersection the surface of the circle M. Here the surface of the circle M. Here the intersection is this line segment. Okay, this line segment is called XY. Okay, and is called the chord of intersection. Okay, so focus about L intersection M or L intersection the surface area. Okay, L intersection M or L intersection the surface. Surface, it means the shaded part as we here in the 3 figures. Okay, so the position of a straight line with respect to a circle, we have here if MA greater than R is called out, L straight line is called outside the circle. If MA equals R, here the straight line is called tangent. Here straight line is called tangent. If the straight line here is called a secant, if MA is smaller than R. So we have here new words, tangent and secant. Okay, we have some examples. Number 1, here we have the radius is 5 centimeter. MA, as we said, perpendicular to the straight line, complete. If AM is 5 centimeters, so here MA equals R. MA equals R, it means the straight line is a tangent. So straight line L is a tangent to the circle M. Okay, here number 2, if AM equals 5 root 3. Okay, if we write 5 root 3 in your calculator, it's greater than 5. So here L is outside the circle. Okay, here AM equals 5 over 2. 5 over 2 is 2.5. So here MA is smaller than R. So L here is called a secant. Okay? Secant to the circle M. Finally, we have 2 important facts. Number 1, the tangent to a circle is perpendicular to the radius from the point of tangency. Okay? First, we have here tangent L is perpendicular to the radius MA from the point of tangency. Point of tangency is here A. It means the straight line L is a tangent to the circle M. Okay, at the point A, as we said, and here MA perpendicular to L. So here we have the measure of this angle is 90 degrees. Second one, the straight line which is perpendicular to a diameter of a circle is called a tangent. Here we have a diameter. Here point A, we have AB is a diameter. Okay, and the diameter here is perpendicular to the straight line L. So here BA is perpendicular to L, the tangent L. It means also if AB is a diameter and L is perpendicular to AB, it means L is a tangent. Okay? So we have here 2 important facts. It's very, very important. Okay? Thank you.